Okay, welcome everyone. So I'm just going to go through the solutions for the latest AdPerfect lesson. So there's 4 questions, I believe, in total. So I've written them down and I'm just going to go through and answer them the way that I would. Okay, so the first one was a temperature question. There was something that, some sort of item and its temperature was changing. And ultimately, in this case, it's going to be decreasing. Find the rate at which the temperature is changing after 5 minutes. So there's more words and stuff, but ultimately this was the question. This formula here gives us the temperature of the object after however many minutes you're looking at. So for example, what was the temperature of the item originally? You'd let T equal 0, you'd plug it in, and you'd end up getting, 52 degrees. If you wanted to know what the temperature is after 5 minutes, you just let T, the little t, over here, you just let that equal 5, right? And this formula here would give you what the temperature is, right? But what we're trying to find is what is the rate at which the temperature is changing? How fast is it heating up, or in this case, cooling down? Now, the first thing to note is the question you may have gotten would have been very similar to this, but you may have had different numbers here and here. And even this number here, a lot of the times you'd end up getting 0.1. But so it depends on what you are. Those numbers seem to be fairly random. But the way you answer the question is going to be exactly the same. So if you've got some slightly different numbers to me, that's okay. You still do everything the same way, but just be aware you end up with a different answer. Okay, so if we want to find the rate at which something is changing, right, we don't want T. What we want is dt. This is the rate at which the temperature is changing with respect to time. In other words, how fast is it heating or cooling? So in other words, we have to differentiate ultimately. So if you want to find the rate at which something is changing, you need to differentiate, and that's going to be what we need to do for every single question. So we need to differentiate this. You differentiate the 12 and it becomes 0. You differentiate the exponential. Remember, when differentiating exponentials, it's the derivative of the f of x comes down the front, and then the exponential remains unchanged afterwards. So differentiating this, so the 12 has vanished, we end up with a 40 times. Okay, what's going to happen with this? We end up with a minus 0.15. That would come down the front, e to the minus 0.15t. Right? Now, if you're still not sure what I've just done there, you need to look back differentiating exponentials. And if you're not sure about it or where to look, you can always just go to YouTube and type it up and find some videos. Make sure you know how to differentiate exponentials. That's a skill we have already covered and you should already know how to do. All right, so we've differentiated the original formula. So this here is going to give us not the temperature, this is going to give us the rate at which the temperature is changing. So that's what we want to find after 5 minutes. So we're just going to let T equal 5, in other words 5 minutes. And so the rate at which this temperature is changing is just going to be given by minus 6 times e to the minus 0.15 times 5. And, ultimately all you need to then do is just type that into your calculator. You press equals, and I believe the program wants you to give your answer to 3 decimal places. So you literally just type it into your calculator. If you're not sure where to find the E on your calculator, you need to press, I believe it's Shift to get it. But actually, it depends on the calculator. You'll find that the calculator will actually have an E right? And if you type it, it should be like a number 2.71 something something. All right, so type it in, press equals, and that first one is done. Right, the next one, now I'm not sure why this was in the prelim course, because we haven't learnt how to differentiate trig. That's going to be something we're going to be covering next term. But anyway, so this one here, I'm actually okay if you skip. I believe to get through it, you'll just need to put in a random answer, which will be wrong, and you can skip straight on to the next one. However, if you're curious, you want to get a head start on how to differentiate trig, I'm just going to quickly do it now. But if you're not interested, and if you want to wait until we officially learn how to differentiate your trig functions, you can skip this part and just wait for it then. But for those that are curious, here we go. So if you want to find this is like the water depth of like water as it goes through the tide. The water goes up and goes back down with the tides. This question isn't asking us to find the water depth at any particular point. It's asking us to find the rate at which the water depth is changing, right? So how fast is the water changing, either going up or down after the 5-hour point? And I think if you read the question carefully, time 0 was at low tide. So this would be like 5 hours after low tide. So presumably the water is now rising as it's going towards high tide. And we're trying to find how fast that water will be rising. Okay, so how do we do it? You want to find the rate of something, right? We're not trying to find W. We're trying to find the rate at which W is changing. In other words, we're differentiating. 4.3, when differentiate becomes a 0. Okay, now we get onto this trig thing. When you differentiate cos, it becomes a negative sign. Okay, so we've got this minus 1.2 out the front, right? When we differentiate cos, it'll become a negative sign. And so I guess I'll start with that. I'll put a negative sign. And what's in there remains completely unchanged. And then you times by, which I normally do before I put the trig in, the derivative of what's inside the trig part. So we have to differentiate that pi t over 6, right? And like I'm saying, if I asked you to differentiate 5x, you'd know that just becomes a 5. If I asked you to differentiate 3t all over 7, when you differentiate it, it'll just become 3 over 7. When you're differentiating, pi t over 6, that's, power down the front, 1 away from the power, right? You just end up with pi over 6. So we times it by the derivative of what's inside the trig, which is pi on 6. And so differentiating, I'm now just going to combine these two things, along with the negative from the sign as well. So the two negatives make a plus, and so you're just left with 1.2 pi all over 6 sine pi t over 6. So this expression here that we've just written, this one right here, does not give us the depth, the water depth at any particular point. It gives us the rate that the water depth is changing. And that's all it's asking us to find after 5 hours. So just like the other one, we're just going to let t equal 5. And so what will be this particular rate of change in the water's depth? And ultimately, this is just typing it into your calculator. Note that we're using radians. There was no angles or anything here. Degrees makes no sense. Radians is the true measure for all real life type scenarios, except for the one scenario where you're calculating an angle. I know we learned trig, finding angles, and our first couple years of trig, everything is just angles. But the majority of the time you're using trig. In the real world, you're not finding an angle, so you're using radians. So just type this into your calculator. Make sure your calculator is in radians mode. and you'll get correct answer. And again, the program wants it to 3 decimal places. And just be aware, you probably already know, you may have got different numbers here and here, but it's all done the same. All right, this one here you can do. Hopefully you've watched the video on differentiating logs. This is the number of mice. So the formula that was given at the top will give you the number of mice, right? The population of mice. What we're trying to find is not how many mice we have. We're trying to find what rate the mice population is increasing after 6 months. So presumably the mice population is increasing because that's what the question is saying. We want to find out how fast is this population increasing. Is it a slow increase? Is it a rapid increase? We're going to find out right now. If you want to find the rate at which something is changing, we're differentiating. We don't want n. We want dn dt. The rate at which n is changing with respect to time. So we go ahead and differentiate. This is fun because we get to differentiate exponential and a logarithm. So go ahead, differentiate the exponential. Take the derivative of what's at top, which is a half. Bring it down the front. And then you times it by the exponential unchanged. To differentiate a logarithm, right? You've seen the video, you've watched it, you know it's simple. All you do is logs turn into fractions. The derivative of what's inside goes up the top. So you differentiate that, just like we always do. And then the thing that was inside the brackets goes on the bottom unchanged. Simplifying, to a degree, you've got a half times 8. I say that because we can obviously simplify the fraction over here. You know what, I will. Those 2's, right? Top and bottom is... I was going to say you don't actually really need to simplify for this question because all we're going to be doing is subbing in the value, subbing in a value for t, plugging it into the calculator. It doesn't matter. But I'm simplifying anyway because it's fun. This expression right here gives us the rate at which the mouse population is changing. If we want to find out how rapidly that population is changing after 6 months, we're going to let t equal 6. We plug it in, and that mouse population is changing and now it just becomes a calculator step again, right? So you got a half times 6. I'm just going to go straight to 3 there. Forgive me. And again, you let in, Okay, so ultimately, you're, again, typing this into your calculator. You're rounding it to 3 decimal places. Plug it into the program. And fingers crossed, we've done everything correct. All right, and the last one is also a combination. We've got a polynomial term here. And we've got a logarithm right here. We're going to be differentiating because we're trying to find the rate. So we get to differentiate both the t squared term and the logarithm. So 2 different differentiations within the one question. By the way, I'm counting 7,000 as also a polynomial term. It's like t to the 0. We know that's just going to become a 0, right? When that power comes down the front. All right, so this was like the population of possums, I believe. That was this question. And they're on an island and they're being trapped. Presumably like as some sort of, sustainability thing as opposed to people eating possums. Although that may be the case. I don't know. Anyway, we want to find the rate of the population is decreasing after 5 months. So they've been trapping these possums for 5 months. And we want to find out after 5 months, not how many possums are left. We're trying to find out how rapidly is that population dropping at the 5-month mark. So you want to find the rate of something. We're not after population. We're after the speed the population is changing, the rate of the population changing with respect to time. So we're differentiating. 7,000 becomes a 0, minus 5t squared, right? Power down the front, 1 away from the power. Differentiating logarithms are heaps of fun. I know I've been saying the word fun a lot, but, you know, differentiating is pretty relaxing, to be honest. Okay, so the logarithm goes away and turns into a fraction. The derivative of what was inside goes at the top. The thing inside unchanged goes on the bottom. And, you know, simplify it if you want to make it neat. Or you can just start subbing in values straight away. But I will make it look more nicer first. And now this expression that we've just found, dp/dt, this will give us the rate the possum population is changing at any particular point. We want to find how rapidly it's decreasing after 5 months. So we're going to let t equal 5. So this, I believe we were using p. So the rate of this population decrease will just be minus 10 times 5 minus 2,800 all over 2 lots of 5 plus the 1. You know, like it would have been easy enough just to go straight to it, let's be honest. But yeah, ultimately, again, another thing you're typing into your calculator, you're going to end up with a negative answer. Relatively large-ish, I don't know, like minus 300 or something. And what that means is at that particular point in time, the possum population is decreasing on the island by about, 300 possums per month, right? So the population's shrinking. Not surprising considering they're deliberately being trapped. Anyway, hopefully this helps. If you have any questions, you know what to do. And I'll see you guys next time. All right, best of luck.